In 2011, early Facebook employee and Cloudera co-founder Jeff Hammerbacher famously said, "The best minds of my generation are thinking about how to get people to click on ads, and that sucks." Let's face it, more than a decade later, organizations continue to be frustrated with how difficult it is to get value from data and build a truly agile, data-driven enterprise. What does that even mean, you ask? Well, it means that everyone in the organization has the data they need when they need it in a context that's relevant to advance the mission of an organization. Now that could mean cutting costs, it could mean increasing profits, driving productivity, saving lives, accelerating drug discovery, making better diagnoses, solving supply chain problems, predicting weather disasters, simplifying processes, and thousands of other examples where data can completely transform people's lives, beyond manipulating internet users to behave a certain way. We've heard the prognostications about the possibilities of data before, and in fairness, we've made progress. But the hard truth is, the original promises of master data management, enterprise data warehouses, data marts, data hubs, and yes, even data lakes were broken and left us wanting for more. Welcome to The Data Doesn't Lie, or does it? A series of conversations produced by theCUBE and made possible by Starburst Data. I'm your host, Dave Vellante, and joining me today are three industry experts. Justin Borgman is the co-founder and CEO of Starburst. Richard Jarvis is the CTO at EMIS Health, and Teresa Tung is cloud-first technologist at Accenture. Today, we're going to have a candid discussion that will expose the unfulfilled and yes, broken promises of a data past. We'll expose data lies, big lies, little lies, white lies, and hidden truths. And we'll challenge age-old data conventions and bust some data myths. We're debating questions like, is the demise of a single source of truth inevitable? Will the data warehouse ever have feature parity with the data lake, or vice versa? Is the so-called modern data stack simply centralization in the cloud, AKA the old guard's model in new cloud clothes? How can organizations rethink their data architectures and regimes to realize the true promises of data? Can and will an open ecosystem deliver on these promises in our lifetimes? We're spanning much of the Western world today. Richard is in the UK, Teresa is on the West Coast, and Justin is in Massachusetts with me. I'm in the CUBE studios about 30 miles outside of Boston. Folks, welcome to the program. Thanks for coming on. Okay,
thanks for having us.
Let's get right into it. You're very welcome. Now, here's the first lie. The most effective data architecture is one that is centralized with a team of data specialists serving various lines of business. What do you think, Justin?
Yeah, definitely a lie. My first startup was a company called Adapt, which was an early SQL engine for Hadoop that was acquired by Teradata. And when I got to Teradata, of course, Teradata is the pioneer of that central enterprise data warehouse model. One of the things that I found fascinating was that not one of their customers had actually lived up to that vision of centralizing all of their data into one place. They all had data silos. They all had data in different systems. They had data on-prem, data in the cloud. You know, those companies were acquiring other companies and inheriting their data architecture. So, you know, despite being the industry leader for 40 years, not one of their customers truly had everything in one place. So I think definitely history has proven that to be a lie.
So Richard, from a practitioner's point of view, you know, what are your thoughts? I mean, there's a lot of pressure to cut costs, keep things centralized, you know, serve the business as best as possible. From that standpoint, what does your experience show?
Yeah, I mean, I think I would echo Justin's experience really, that we as a business have grown up through acquisition, through storing data in different places, sometimes to do information governance in different ways, to store data in a platform that's close to data experts, people who really understand healthcare data from pharmacies or from doctors. And so although if you were starting from a greenfield site and you were building something brand new, you might be able to centralize all the data and all of the tooling and teams in one place. The reality is that businesses just don't grow up like that. And it's just really impossible to get that academic perfection of storing everything in one place.
You know, Teresa, I feel like Sarbanes-Oxley kind of saved the data warehouse, you know, right? You actually did have to have a single version of the truth for certain financial data. But really, for some of those other use cases I mentioned, I do feel like the industry has kind of let us down. What's your take on this? Where does it make sense to have that sort of centralized approach versus where does it make sense to maybe decentralized?
I think you got to have centralized governance, right? So from the central team for things like Sarbanes-Oxley, for things like security, for certain very core data sets, having a centralized set of roles, responsibilities to really QA, right? To serve as a design authority for your entire data estate, just like you might with security. But how it's implemented has to be distributed. Otherwise, you're not going to be able to scale, right? So being able to have different parts of the business really make the right data investments for their needs. And then ultimately, you're going to collaborate with your partners. So partners that are not within the company, right? External partners, we're going to see a lot more data sharing and model creation. And so you're definitely going to be decentralized.
So, Justin, you guys I think it was about a year ago, had a session on data mesh. It was a great program. You invited AMY-VOGT in. Of course, she's the creator of the data mesh. And one of her fundamental premises is that you've got this hyper specialized team that you've got to go through if you want anything. But at the same time, these individuals actually become a bottleneck, even though they're some of the most talented people in the organization. So I guess question for you, Richard, how do you deal with that? Do you organize so that there are a few sort of rock stars that build cubes and the like, and or have you had any success in sort of decentralizing with your constituencies that data model?
Yeah, so we absolutely have got rockstar data scientists and data guardians, if you like, people who understand what it means to use this data, particularly as the data that we use at EMIS is very private, it's healthcare information, and some of the rules and regulations around using the data are very complex and strict. So we have to have people who understand the usage of the data, then people who understand how to build models, how to process the data effectively. And you can think of them like consultants to the wider business, because a pharmacist might not understand how to structure a SQL query, but they do understand how they want to process medication information to improve patient lives. And so that becomes a consulting type experience from a set of rock stars to help a more decentralized business who needs to understand the data and to generate some valuable output.
Justin, what do you say to a customer or prospect that says, look, Justin, I got a centralized team and that's the most cost-effective way to serve the business. Otherwise, I got duplication. What do you say to that?
Well, I would argue it's probably not the most cost-effective, and the reason being really twofold. I think, first of all, when you are deploying a enterprise data warehouse model, the data warehouse itself is very expensive, generally speaking. And so you're putting all of your most valuable data in the hands of one vendor who now has tremendous leverage over you, for many, many years to come. I think that's the story of Oracle or Teradata or other proprietary database systems. But the other aspect, I think, is that the reality is those central data warehouse teams, as much as they are experts in the technology, they don't necessarily understand the data itself. And this is one of the core tenets of data mesh that Zhamak writes about, is this idea of the domain owners actually know the data the best. And so by not only acknowledging that data is generally decentralized, and to your earlier point about Sarbanes-Oxley maybe saving the data warehouse, I would argue maybe GDPR and data sovereignty will destroy it, because data has to be decentralized for those laws to be compliant. But I think the reality is, the data mesh model basically says data is decentralized, and we're going to turn that into an asset rather than a liability. And we're going to turn that into an asset by empowering the people that know the data the best to participate in the process of, curating and creating data products for consumption. So I think when you think about it that way, you're going to get higher quality data and faster time to insight, which is ultimately going to drive more revenue for your business and reduce costs. So I think that's the way I see the two models, comparing and contrasting.
So do you think the demise of the data warehouse is inevitable? I mean, Teresa, you work with a lot of clients. They're not just going to rip and replace their existing infrastructure. Maybe they're going to build on top of it. But what does that mean? Does that mean the EDW just becomes less and less valuable over time, or it's maybe just isolated to specific use cases? What's your take on that?
Listen, I still would love all my data within a data warehouse. Would love it mastered, would love it owned by a central team, right? I think that's still what I would love to have. That's just not the reality, right? The investment to actually migrate and keep that up to date, I would say it's a losing battle. Like, we've been trying to do it for a long time. Nobody has the budgets, and then data changes, right? There's going to be a new technology that's going to emerge that we're going to want to tap into. There's going to be not enough investment to bring all the legacy, but still very useful systems into that centralized view. So you keep the data warehouse. I think it's a very, very valuable, very high performance tool for what it's there for. But you could have this new mesh layer that still takes advantage of the things I mentioned, the data products and the systems that are meaningful today, and the data products that actually might span a number of systems. Maybe either those that either source systems for the domains that know it best, or the consumer-based systems or products that need to be packaged in a way to be really meaningful for that end user, right? Each of those are useful for a different part of the business, and making sure that the mesh actually allows you to use all of them.
So Richard, let me ask you, take Zhamak's principles back to those. You got, the domain ownership and data as product. Okay, great, sounds good. But it creates what I would argue are two challenges. Self-serve infrastructure, let's park that for a second. And then in your industry, one of the most regulated, most sensitive, computational governance. How do you automate and ensure federated governance in that mesh model that Teresa was just talking about?
Well, it absolutely depends on some of the tooling and processes that you put in place around those tools to centralize the security and the governance of the data. And I think, although a data warehouse makes that very simple because it's a single tool, it's not impossible with some of the data mesh technologies that are available. And so what we've done at EMIS is we have a single security layer that sits on top of our data mesh, which means that no matter which user is accessing which data source, we go through a well-audited, well-understood security layer. That means that we know exactly who's got access to which data field, which data tables, and then everything that they do is audited in a very kind of standard way, regardless of the underlying data storage technology. So for me, although storing the data in one place might not be possible, understanding where your source of truth is and securing that in a common way is still a valuable approach. And you can do it without having to bring all that data into a single bucket so that it's all in one place. And so having done that and investing quite heavily in making that possible has paid dividends in terms of giving wider access to the platform and ensuring that only data that's available under GDPR and other regulations is being used by the data users.
Yeah, so Justin, I mean, we always talk about data democratization, and up until recently, there really haven't been line of sight as to how to get there. But do you have anything to add to this? Because you're essentially taking, doing analytic queries and with data that's all dispersed all over. How are you seeing your customers handle this challenge?
Yeah, I mean, I think data products is a really interesting aspect of the answer to that. It allows you to, again, leverage the data domain owners, people know the data the best, to create, data as a product ultimately to be consumed. And we try to represent that in our product as effectively a almost e-commerce-like experience where you go and discover and look for the data products that have been created in your organization, and then you can start to consume them as you'd like. And so really trying to build on that notion of, data democratization and self-service, and making it very easy to discover and start to use with whatever BI tool you may like, or even just running, SQL queries yourself.
Okay, guys, grab a sip of water. After this short break, we'll be back to debate whether proprietary or open platforms are the best path to the future of data excellence. Keep it right there.
Your company has more data than ever, and more people trying to understand it. But there's a problem. Your data is stored across multiple systems. It's hard to access, and that delays analytics and ultimately decisions. The old method of moving all of your data into a single source of truth is slow and definitely not built for the volume of data we have today or where we are headed. While your data engineers spend over half their time moving data, your analysts and data scientists are left waiting, feeling frustrated, unproductive, and unable to move the needle for your business. But what if you could spend less time moving or copying data? What if your data consumers could analyze all your data quickly? Starburst helps your teams run fast queries on any data source. We help you create a single point of access to your data no matter where it's stored, and we support high concurrency. We solve for speed and scale. Whether it's fast SQL queries on your data lake or faster queries across multiple data sets, Starburst helps your teams run analytics anywhere. You can't afford to wait for data to be available. Your team has questions that need answers now. With Starburst, the wait is over. You'll have faster access to data with enterprise-level security, easy connectivity, and 24/7 support from experts. Organizations like Zalando, Comcast, and FINRA rely on Starburst to move their businesses forward. Contact our Trino experts to get started.
We're back with Jessamine Borgman of Starburst and Richard Jarvis of EMIS Health. Okay, we're going to get into lie number 2, and that is this. An open source-based platform cannot give you the performance and control that you can get with a proprietary system. Is that a lie? Justin, the enterprise data warehouse has been pretty dominant and has evolved and matured. Its stack has matured over the years. Why is it not the default platform for data?
Yeah, well, I think that's become a lie over time. So I think, if we go back 10 or 12 years ago with the advent of the first data lake, really around Hadoop, that probably was true, that you couldn't get the performance that you needed to run fast, interactive SQL queries in a data lake. Now, a lot's changed in 10 or 12 years. I remember in the very early days, people would say, you'll never get performance because you need to be columnar. You need to store data in a columnar format. Mm-hmm. And then, columnar formats were introduced to data lakes. You have Parquet, ORC file, and Abro that were created to ultimately deliver performance out of that. So, okay, we got, largely over the performance hurdle. More recently, people will say, well, you don't have the ability to do updates and deletes like a traditional data warehouse. And now we've got the creation of new data formats again, like Iceberg and Delta and Hootie that do allow for updates and deletes. So I think the data lake has continued to mature. And I remember a quote from Kurt Monash many years ago where he said, it takes 6 or 7 years to build a functional database. I think that's right. And now we've had almost a decade go by. So, these technologies have matured to really deliver very, very close to the same level of performance and functionality of cloud data warehouses. So I think the reality is that's become a lie. And now we have large, giant, hyperscale internet companies that don't have the traditional data warehouse at all. They do all of their analytics in a data lake. So I think we've proven that it's very much possible today.
Thank you for that. So Richard, talk about your perspective as a practitioner in terms of what open brings you versus, look, closed open is a moving target. I remember Unix used to be open systems. And so it's an evolving spectrum. But from your perspective, what does open give you that you can't get from a proprietary system or you're fearful of in a proprietary system?
I suppose for me, open buys us the ability to be unsure about the future, because one thing that's always true about technology is it evolves in a direction slightly different to what people expect. And what you don't want to end up has done is backed itself into a corner that then prevents it from innovating. So if you have chosen a technology and you've stored trillions of records in that technology, and suddenly a new way of processing or machine learning comes out, you want to be able to take advantage, and your competitive edge might depend upon it. And so I suppose for us, we acknowledge that we don't have perfect vision of what the future might be. And so by backing open storage technologies, we can apply a number of different technologies to the processing of that data. And that gives us the ability to remain relevant, innovate on our data storage. And we have bought our way out of any performance concerns because we can use cloud scale infrastructure to scale up and scale down as we need. And so we don't have the concerns that we don't have enough hardware today to process what we want to achieve. We can just scale up when we need it and scale back down. So open source has really allowed us to maintain being at the cutting edge.
So Justin, let me play devil's advocate here a little bit. And I've talked to Zhamak about this, and obviously her vision is there's an open source, that data mesh is open source tooling, and it's not a proprietary, you're not going to buy a data mesh, you're going to build it with open source toolings, and vendors like you are going to support it. But to come back to sort of today, you can get to market with a proprietary solution faster. I'm going to make that statement. You tell me if it's a lie. And then you can say, okay, we support Apache Iceberg. We're going to support open source tooling. Take a company like VMware, not really in the data business, but how the way they embraced Kubernetes and every new open source thing that comes along, they say, oh, we do that too. Why can't proprietary systems do that and be as effective?
Yeah, well, I think at least within the data landscape, saying that you can access open data formats like Iceberg or others is a bit disingenuous, because really what you're selling to your customer is a certain degree of performance, a certain SLA. And those cloud data warehouses that can reach beyond their own proprietary storage drop all the performance that they were able to provide. So it reminds me kind of again, going back 10 or 12 years ago, when everybody had a connector to Hadoop, and that they thought that was the solution, right? But the reality was, a connector was not the same as running workloads in Hadoop back then. And I think similarly, being able to connect to an external table that lives in an open data format, you're not going to give it the performance that your customers are accustomed to. And at the end of the day, they're always going to be predisposed. They're always going to be incentivized to get that data ingested into the data warehouse, because that's where they have control. And the bottom line is the database industry has really been built around vendor lock-in. I mean, from the start. How many people love Oracle today, but are customers nonetheless? I think lock-in is part of this industry, and I think that's really what we're trying to change with open data formats.
Well, it's interesting. I'm reminded of when I see the gas price, the teaser gas price. I drive up and then I say, oh, that's the cash price. It's a credit card, I'm going to pay 20 cents more. But okay. But so the argument then, so let me come back to you, Justin. So what's wrong with saying, hey, we support open data formats, but yeah, you're going to get better performance if you keep it into our closed system? Are you saying that long term, that's going to come back and bite you, because you're going to end up, you mentioned Oracle, you mentioned Teradata, that's, by implication, you're saying that's where Snowflake customers are headed.
Yeah, absolutely. I think this is a movie that, we've all seen before, at least those of us who've been in the industry long enough to see this movie play over a couple times. So I do think that's the future. And I think, I loved what Richard said. I actually wrote it down because I thought it was an amazing quote. He said, it buys us the ability to be unsure of the future. That pretty much says it all. The future is unknowable. And the reality is, using open data formats, you remain interoperable with any technology you want to utilize. If you want to use Spark to train a machine learning model, and you want to use Starburst to query it via SQL, that's totally cool. They can both work off of the same exact data sets. By contrast, if you're focused on a proprietary model, then you're kind of locked in again to that model. I think the same applies to data sharing, to data products, to a wide variety of aspects of the data landscape that a proprietary approach kind of closes you in and locks you in.
So I would say this, Richard, I'd love to get your thoughts on it, because I talked to a lot of Oracle customers, not as many Teradata customers, but a lot of Oracle customers, and they, they'll admit, they're jamming us on price and the license costs are good, but we do get value out of it. And so my question to you, Richard, is do let's call it data warehouse systems or the proprietary systems, are they going to deliver a greater ROI sooner? And is that an allure of that customers are attracted to, or can open platforms deliver as fast an ROI?
I think the answer to that is it can depend a bit. It depends on your business's skill set. So we're lucky that we have a number of proprietary teams that work in databases that provide our operational data capability. And we have teams of analytics and big data experts who can work with open data sets and open data formats. And so for those different teams, they can get to an ROI more quickly with different technologies. For the business, though, we can't do better for our operational data stores than proprietary databases today. We can back off very tight SLAs to them. We can demonstrate reliability from millions of hours of those databases being run at enterprise scale. But for an analytics workload where increasingly our business is growing in that direction, we can't do better than open data formats with cloud-based data mesh type technologies. And so it's not a simple answer that one will always be the right answer for our business. We definitely have times when proprietary databases provide a capability that we couldn't easily replicate with open technologies.
Yeah, Richard, stay with you. You mentioned, some things before that strike me. The Databricks Snowflake, thing is always a lot of fun for analysts like me. You've got Databricks coming at it. Richard, you mentioned you have a lot of rock star data engineers. Databricks coming at it from a data engineering heritage. You get Snowflake coming at it from an analytics heritage. Those two worlds are colliding. People like Sanjeev Mohan has said, you know what, I think it's actually harder to play in the data engineering. So i.e. it's easier for data engineering world to go into the analytics world versus the reverse. But thinking about up and coming engineers and developers preparing for this future of data engineering and data analytics, how should they be thinking about the future? What's your advice to those young people?
So I think I'd probably fall back on general programming skill sets. So the advice that I saw years ago was if you have open source technologies, the Pythons and Javas on your CV, you command a 20% pay hike over people who can only do proprietary programming languages. And I think that's true of data technologies as well. And from a business point of view, that makes sense. I'd rather spend the money that I save on proprietary licenses on better engineers because they can provide more value to the business that can innovate us beyond our competitors. So I think my advice to people who are starting here or trying to build teams to capitalize on data assets is begin with open, license-free capabilities because they're very cheap to experiment with. And they generate a lot of interest from people who want to join you as a business, and you can make them very successful early doors with your analytics journey.
And it's interesting, again, analysts like myself, we do a lot of TCO work and have over the last 20 plus years. And in the world of Oracle, normally it's the staff that's the biggest nut in total cost of ownership. Not in Oracle, it's the license cost is by far the biggest component in the blame pie. All right, Justin, help us close out this segment. We've been talking about this sort of data mesh, open, closed, Snowflake, Databricks. Where does Starburst sort of as this engine for the data lake house, the data warehouse, it fit in this world?
Yeah, so our view on how the future ultimately unfolds is we think that data lakes will be a natural center of gravity for a lot of the reasons that we described: open data formats, lowest total cost of ownership because you get to choose the cheapest storage available to you. Maybe that's S3 or Azure Data Lake Storage or Google Cloud Storage, or maybe it's on-prem object storage that you bought at a really good price. So ultimately storing a lot of data in a data lake makes a lot of sense. But I think what makes our perspective unique is we still don't think you're going to get everything there either. We think that basically centralization of all your data assets is just an impossible endeavor. And so you want to be able to access data that lives outside of the lake as well. So we kind of think of the lake as maybe the biggest place by volume in terms of how much data you have. But to have comprehensive analytics and to truly understand your business and understand it holistically, you need to be able to go access other data sources as well. And so that's the role that we want to play, is to be a single point of access for our customers provide the right level of fine-grained access controls so that the right people have access to the right data, and ultimately make it easy to discover and consume via the creation of data products as well.
Great. Okay, thanks guys. Right after this quick break, we're going to be back to debate whether the cloud data model that we see emerging and the so-called modern data stack is really modern, or is it the same wine, new bottle when it comes to data architectures? You're watching theCUBE, the leader in enterprise and emerging tech coverage.
Your data is capable of producing incredible results, but data consumers are often left in the dark without fast access to the data they need. Starburst makes your data visible from wherever it lives. Your company is acquiring more data in more places more rapidly than ever. To rely solely on a data centralization strategy, whether it's in a lake or a warehouse, is unrealistic. A single source of truth approach is no longer viable, but disconnected data silos are often left untapped. We need a new approach, one that embraces distributed data, one that enables fast and secure access to any of your data from anywhere. With Starburst, you'll have the fastest query engine for the data lake that allows you to connect and analyze your disparate data sources, no matter where they live. Starburst provides the foundational technology required for you to build towards the vision of a decentralized data mesh. Starburst Enterprise and Starburst Galaxy offer enterprise-ready connectivity, interoperability, and security features for multiple regions, multiple clouds, and ever-changing global regulatory requirements. The data is yours, and with Starburst, you can perform analytics anywhere and light up your world.
Okay, we're back with Justin Borgman, CEO of Starburst. Richard Jarvis is the CTO of EMIS Health, and Teresa Tung is the cloud-first technologist from Accenture. We're on to lie number 3, and that is the claim that today's modern data stack is actually modern. So I guess that's a lie, or is that it's not modern. Justin, what do you say?
Yeah, I mean, I think new isn't modern, right? I think it's the new data stack, it's the cloud data stack, but that doesn't necessarily mean it's modern. I think a lot of the components actually are exactly the same as what we've had for 40 years. Rather than Teradata, you have Snowflake. Rather than Informatica, you have Fivetran. So it's the same general stack, just a cloud version of it. And I think a lot of the challenges that have plagued us for 40 years still maintain.
So let me come back to you, Justin. But okay, but there are differences, right? I mean, you can scale, you can throw resources at the problem, you can separate compute from storage. You really, there's a lot of money being thrown at that by venture capitalists, and Snowflake, you mentioned, its competitors. So that's different, is it not? Is that not at least an aspect of modern? Dial it up, dial it down. So what do you say to that?
Well, it is. It's certainly taking, what the cloud offers and taking advantage of that. But it's important to note that the cloud data warehouses out there are really just separating their compute from their storage. So it's allowing them to scale up and down, but your data is still stored in a proprietary format. You're still locked in. You still have to ingest the data to get it even prepared for analysis. So a lot of the same sort of structural constraints that exist with the old enterprise data warehouse model on-prem still exists, just yes, a little bit more elastic now because the cloud offers that.
So Teresa, let me go to you because you have cloud first in your title. So what say you to this conversation?
Well, even the cloud providers are looking towards more of a cloud continuum, right? So the centralized cloud as we know it, maybe data lake, data warehouse in a central place, that's not even how the cloud providers are looking at it. They have new query services. Every provider has one that really expands those queries to be beyond a single location. And if we look at a lot of where the future goes, right, that's going to very much follow the same thing. There was going to be more edge. There's going to be more on-premise because of data sovereignty, data gravity, because you're working with different parts of the business that have already made major cloud investments in different cloud providers. Right. So there's a lot of reasons why the next modern generation of the data stack needs to be much more federated.
Okay, so Richard, how do you deal with this? You've obviously got, the technical debt, the existing infrastructure. It's on the books. You don't want to just throw it out. A lot of conversation about modernizing applications, which a lot of times is a microservices layer on top of legacy apps. How do you think about the modern data stack?
Well, I think probably the first thing to say is that the stack really has to include the processes and people around the data as well. It's all well and good changing the technology, but if you don't modernize how people use that technology, then you're not going to be able to scale, because just because you can scale CPU and storage doesn't mean you can get more people to use your data to generate you more value for the business. And so what we've been looking at is really changing in very much aligned to data products and data mesh. How do you enable more people to consume the service and have the stack respond in a way that keeps costs low, because that's important for our customers consuming this data, but also allows people to occasionally run enormous queries and then tick along with smaller ones when required. And it's a good job we did, because during COVID, all of a sudden we had enormous pressures on our data platform to answer really important life-threatening queries. And if we couldn't scale both our data stack and our teams, we wouldn't have been able to answer those as quickly as we had. So I think the stack needs to support a scalable business, not just the technology itself.
Well, thank you for that. So Justin, let's try to break down what the critical aspects are of the modern data stack. So you think about the past 5-7 years. Cloud obviously has given a different pricing model, de-risked experimentation, that we talked about, the ability to scale up, scale down. But I'm taking away that that's not enough. Based on what Richard just said, the modern data stack has to serve the business and enable the business to build data products. I buy that. I'm a big fan of the data mesh concepts, even though we're early days. So what are the critical aspects, if you had to think about, maybe putting some guardrails and definitions around the modern data stack, what does that look like? What are some of the attributes and principles there?
Of how it should look like, or
yeah,
how
what it should be?
Yeah. Well, I think, and Teresa mentioned this in a previous segment about the data warehouse is not necessarily going to disappear. It just becomes one node, one element of the overall data mesh. And I certainly agree with that. So by no means are we suggesting that, Snowflake or Redshift or whatever cloud data warehouse you may be using is going to disappear, but it's not going to become the end all be all. It's not the central single source of truth. And I think that's the paradigm shift that needs to occur. And I think it's also worth noting that those who were the early adopters of the modern data stack were primarily digital native, born in the cloud, young companies who had the benefit of idealism. They had the benefit of starting with a clean slate. That does not reflect the vast majority of enterprises. And even those companies, as they grow up, mature out of that ideal state. They go buy a business. Now they've got something on another cloud provider that has a different data stack, and they have to deal with that heterogeneity. That is just change, and change is a part of life. And so I think there is an element here that is almost philosophical. It's like, do you believe in an absolute ideal where I can just fit everything into one place, or do I believe in reality? And I think the far more pragmatic approach is really what data mesh represents. So to answer your question directly, I think it's adding the ability to access data that lives outside of the data warehouse, maybe living in open data formats in a data lake, or accessing operational systems as well. Maybe you want to directly access data that lives in an Oracle database or a Mongo database or what have you. So creating that flexibility to really future-proof yourself from the inevitable change that you will encounter over time.
So thank you. So Teresa, based on what Justin just said, my takeaway there is it's inclusive, whether it's a data mart, data hub, data lake, data warehouse. It's just a node on the mesh. Okay, I get that. Does that include, Teresa, on-prem data? Obviously it has to. What are you seeing in terms of the ability to take that data mesh concept on-prem? I mean, most implementations I've seen on data mesh, frankly, really aren't adhering to the philosophy there. Maybe it's a data lake, and maybe it's using Glue. You look at what JPMC is doing, HelloFresh, a lot of stuff happening on the AWS cloud in that, closed stack, if you will. What's the answer to that, Teresa?
I mean, I think it's a killer case for data mesh. The fact that you have valuable data sources on-prem, and then yet you still want to modernize and take the best of cloud. Cloud is still, like we mentioned, there's a lot of great reasons for it around the economics and the ability to tap into the innovation that the cloud providers are giving around data and AI architecture. It's an easy button. So the mesh allows you to have the best of both worlds. You can start using the data products on-prem or in the existing systems that are working already. It's meaningful for the business. At the same time, you can modernize the ones that make business sense because it needs better performance. It needs something that is cheaper or maybe just tap into better analytics to get better insights, right? So you're going to be able to stretch and really have the best of both worlds. That, again, going back to Richard's point, that is needful by the business. Not everything has to have that one size fits all set of tools.
Okay, thank you. So Richard, we're talking about data as product. I wonder if you could give us your perspectives here. What are the advantages of treating data as a product? What role do data products have in the modern data stack? We talk about monetizing data. What are your thoughts on data products?
So for us, one of the most important data products that we've been creating is taking data that is healthcare data across a wide variety of different settings. So information about patients' demographics, about their treatment, about their medications and so on, and taking that into a standards format that can be utilized by a wide variety of different researchers. Because misinterpreting that data or having the data not presented in the way that the user is expecting means that you generate the wrong insight. And in any business, that's clearly not a desirable outcome. But when that insight is so critical as it might be in healthcare or some security settings, you really have to have gone to the trouble of understanding the data, presenting it in a format that everyone can clearly agree on, and then letting people consume in a very structured and managed way, even if that data comes from a variety of different sources in the first place. And so our data product journey has really begun by standardizing data across a number of different silos through the data mesh so we can present it out both internally and through the right governance externally to researchers.
So that data product through whatever APIs is accessible, it's discoverable, but it's obviously got to be governed as well. You mentioned you appropriately provided to internally, but also external folks as well. So you've architected that capability today.
We have, and because the data is standard, it can generate value much more quickly, and we can be sure of the security and value that that's providing. Because the data product isn't just about formatting the data into the correct tables, it's understanding what it means to redact the data or to remove certain rows from it or to interpret what a date actually means. Is it the start of the contract or the start of the treatment or the date of birth of a patient? These things can be lost in the data storage without having the proper product management around the data to say in a very clear business context, what does this data mean and what does it mean to process this data for a particular use case? Yeah,
it makes sense. It's got the context. If the domains own the data, you got to cut through a lot of the centralized teams, the technical teams, they're data agnostic. They don't really have that context. All right, let's end. Justin, how does Starburst fit into this modern data stack? Bring us home.
Yeah, so I think for us, it's really providing our customers with, the flexibility to operate and analyze data that lives in a wide variety of different systems, ultimately giving them that optionality. And optionality provides the ability to reduce costs, store more in a data lake rather than a data warehouse. It provides the ability for the fastest time to insight, to access the data directly where it lives. And ultimately, with this concept of data products that we've now incorporated into our offering as well, you can really create and curate data as a product to be shared and consumed. So we're trying to help enable the data mesh model and make that an appropriate complement to the modern data stack that people have today.
Excellent. Hey, I want to thank Justin, Teresa, and Richard for joining us today. You guys are great. We're big believers in the data mesh concept, and I think we're seeing the future of data architecture. So thank you. Now remember, all these conversations are going to be available on thecube.net for on-demand viewing. You can also go to starburst.io. They have some great content on the website, and they host some really thought-provoking interviews and they have awesome resources. Lots of data mesh conversations over there and really good stuff in the resource section, so check that out. Thanks for watching. The data doesn't lie, or does it? Made possible by Starburst Data. This is Dave Vellante for theCUBE, and we'll see you next time.
The explosion of data sources has forced organizations to modernize their systems and architecture, and come to terms with one size does not fit all for data management. Today, your teams are constantly moving and copying data, which requires time, management, and in some cases, double paying for compute resources. Instead, what if you could access all your data anywhere, using the BI tools and SQL skills your users already have? And what if this also included enterprise security and fast performance? With Starburst Enterprise, you can provide your data consumers with a single point of secure access to all of your data, no matter where it lives. With features like strict fine-grained access control, end-to-end data encryption, and data masking, Starburst meets the security standards of the largest companies. Starburst Enterprise can easily be deployed anywhere and managed with insights, where data teams holistically view their cluster's operation and query execution so they can reach meaningful business decisions faster. All this with the support of the largest team of Trino experts in the world, delivering fully tested, stable releases and available to support you 24/7. To unlock the value in all of your data, you need a solution that easily fits with what you have today and can adapt to your architecture tomorrow. Starburst Enterprise gives you the fastest path from big data to better decisions, because your team can't afford to wait. Trino was created to empower analytics anywhere, and Starburst Enterprise was created to give you the enterprise-grade performance, connectivity, security, management, and support your company needs. Organizations like Zalando, Comcast, and FINRA rely on Starburst to move their businesses forward. Contact us to get started.